Hello students, this is Mr. Rosado. I'm going to give you a little tutorial on writing a two-column algebraic proof involving angles. If you look at the diagram, we have two angles, KLM and MLN, and then there's a large angle, KLN. The given information is that the ray LM bisects angle KLN, and we need to prove that the measure of angle MLN is 80 degrees. So we can't just show our algebra work and then just say, okay, there's the answer. We need to actually outline every single step for this problem. So whenever you start with a problem, you start with the given. Now, your two-column proof will have two columns, the statements column and the reasons column. The statements are usually equations or statements of equality, and that's the side where we actually see algebra going on. The reasons are usually properties, definitions, and that's like our why. So if we have a statement on the left, the reason is why we wrote that statement. Okay? So our first statement is going to be LM bisects angle KLN. And the reason why I wrote that, you see I'm saying why, is because it is given. It's told to us in the original problem. So our reason will be given. And when you complete these proofs, you always put the line number next to each part. So line 1 is this whole thing here. Alright, now let's move on to the next part. Now, to get from one line to the next, we have to use our deductive reasoning. We have to draw conclusions about what's given to us. So when you look at this, you should be thinking in your mind, okay, what do I know about an angle bisector? Well, I know that if a ray is an angle bisector, that means the angles are congruent, which means they are equal in measure. So what I can conclude about statement 1 is that angle MLN is equal to angle KLM. Alright, that's my conclusion. Now, the reason I can write that conclusion, and this is the why part, this is the reason, is because I have an angle bisector. If I have an angle bisector, then I have equal angles. Alright, those two statements I just said, if then, that's a conditional. Okay, it's also reversible in this diagram. If the two angles are congruent, then we have an angle bisector. So we have a definition here. Okay, if I have equal angles, then there's an angle bisector. If there's an angle bisector, then there are equal angles. Okay, that's why we practice writing the biconditional and deconstructing the biconditional. So this second line, the reason that these are equal is because of the definition of an angle bisector. And you would have to write that. Step 3. Well, remember in class when I gave you those steps on how to solve a problem like this, you have to identify the angle pair and then either set it equal or they add up to 90 or 180. Well, now this is where we actually do that. Now we're going to replace the angles here with what they are in the diagram. See, we know what these angles are. They're these little expressions right here. So let's go ahead and substitute that in. So MLN is 4x degrees. KLM is 2x plus 40 degrees. Okay? And that is not a geometric property or definition. That's actually an algebra property we used. Okay, so that's known as the substitution property. That's why I wrote this. Okay, I wrote this because, and the reason as to why, I knew that they were equal to these, so I substitute. So this is substitution. Okay. So now we're at this point. Now it's like all algebra. We can start moving variables around, but we just have to keep track of the algebra we're doing. Okay, so I'm going to slide the paper up a little bit to get a little bit more room. Step 4, or line 4 I should say, I have to start solving for x. So if I minus the 2x over, I'm going to get 2x's equal to 40. Okay? So I minus the 2x. See, now we don't usually write it in the proof here, but I'm just writing it lightly so you can see how I got that. So that's step 4. That's subtraction. Right? Subtraction. I bet you can guess what the next step is. I'll give you a second to think about it and say it to yourself. Okay, what do you think it is? Yes, it is division. If you notice, I can divide a 2 out and I'll get that x equals 20. Alright, and that was the division property. That's line 5. Now at this point here, you know, this is like that typical homework problem, solve for x. Well, we're not done yet because we need to prove that the angle MLN is 80 degrees. So now I have to do that part where I plug back in, and there are actual algebra steps for that. So this is step number 6. I mean line number 6. Angle MLN is going to equal 4 times 20. So all I did was I took the 20 that was here and I substituted it in for the 4x over here. So as I just said, that's a substitution reason. That's why I wrote this. Remember, the reasons here are the whys. Okay. So now I have one more line of work. Some students don't like showing this part because it's like, wait a minute, duh, I know that already. So why am I writing it? Well, what we have to do now is we have to write that we simplified. So angle MLN equals 80. And our reason is because, the why, because we simplified. That is a legitimate reason. All right. Okay, so that's a basic rundown of these proofs. These algebra proofs can get pretty long sometimes. As you can see, this is 7 lines. Later on in the school year, when we start proving triangles, like overlapping triangles congruent, and or parts of other shapes congruent, you'll see that these proofs can get quite lengthy, but we can handle them. All right. So make sure you work hard, study well, and you know, re-watch this video if you have to. I know in the homework sometimes I'll have this same problem, and you can refer back to it and fill in the missing parts. Okay. Hello, students. It is Mr. Rosado. I'm going to show you how to bisect an angle, or in more precise terms, we are going to construct the angle bisector. And all we're going to use is our handy dandy compass and a straight edge. Alright, so we're given this angle, angle A, and we want to have a ray go through it, so it divides the angle into 2 equal rays that are smaller than the original one. So let's see. First, place the needle at the vertex of the angle A. Draw an arc with the compass that goes through the sides, like that. Next, set the compass aside you're going to call the intersections of the arc with the sides of the angle A point H and point T. Next, you're going to take the compass and you're going to use the same compass setting. You are not going to change it. So do not make the compass setting wider or smaller. Place the needle on point H and you're going to make an arc that's in the interior of the angle A, like that. So make sure you're following what I'm doing. Then you're going to transfer the compass from H, the needle from H to point T, and you're going to keep the same compass setting and make a similar arc. And when you do this, you will notice that the two arcs, these two new arcs, intersect. We are now done with the compass, so you can set it aside. Call the intersection of the two arcs X, because remember, X marks the spot. Now, with the straight edge, we are going to draw a ray starting at the vertex A through the point X that we just marked. And there you go. So this ray is dividing the large original angle A into two smaller congruent angles. So what does this mean? Well, it means we can write down some relationships. First off, these two angles are congruent, so put an arc marking like that through the two little acute angles. And we will write the following. The ray AX bisects angle HAT. And what does that actually mean? What it means is that these two angles are congruent. Angle HAX is congruent to angle XAT. There are other relationships that you can show in this diagram. I'll let you figure out those on your own. I hope you enjoyed.